Hello and welcome to my solution video of the golden idol case, one of the many interesting cases of this year's Microsoft Excel World Championship. Okay, I'm going to get started and I'm going to try to explain what I'm doing in the process. So I'm not sure if this will land me within half an hour, but we have to find out. Okay, first what I'm going to do is I'm going to copy my own personal preparation sheet into the workbook. Advantage of that is that I have my personal lambdas and also have some other nice things here. So I need to replace this with nothing, so the formulas actually start to work. And here I see the pre-created data table, the input, the selection, levels, and the answers. Yeah, so it's a good starting point. Now I'm going to actually create the maze. So I'm going to say this and this gives the maze, gives the coordinates, but I want to call it, so I can use it as a lookup table. And I'm also going to call the maze itself. And then what I'm going to do, I'm going to copy paste this and I'm going to say filter the maze and this is not supposed to be a brick, so I get only the fields where I can actually walk on. And then this I'm going to call temple 1. Okay, let's do the same for temple 2. You can actually use trim range. Row 1 and trim range column A. Does the same. See, I do use the mouse. Now I want to filter this whole thing. Say I don't want to see any bricks. Okay, I'll call this temple 2. And then this one is the big one. Okay, so the trim range formula can actually be copied, I think. Only this has to be A to A. See, Excel gets a bit slow. B2 to filtering again, hashtag to DA1 to by DA2 hashtag is not equal to a brick. Well, I lost my brick. B2. I'm gonna call this temple 3. Okay. That's it. It's the last time we're going to look at these temples, I think. Now what I want is to see temple 1 and I want to use it as a lookup. So I'm going to get, so I'm just basically going to say if h3 equals temple 1, I want to see temple 1. If h3 is temple 2, I want to see temple 2, and otherwise I want to see temple 3, but I only want to see the first column here and then the second column here, so I can actually use it as a lookup. Okay, So what are my potential starting cells? My potential starting cells are the ones that actually have this checkered flag here. So I'm going to say transpose, let's do it here, give me a little bit of space in the top, transpose, I want to filter the starting cells by these equals the checkered flag. Let's do F9 here. So these are my starting cells for level 1. And you'll see that it will also work for temple 2. Different set of starting cells. Okay, nice. Now we start in C2, but what is our next cell? To know that, I have created, well, one of my functions, one of my pre-created lambdas is called trace path. And what trace path does, it wants an address and then it wants a direction, and direction can be very broad. So for example, it can be east, and then you can do a number. For example, you want to go 5 to the east, and then it traces a path of 5 cells towards the east, being to the right. Okay, but in this case we only want one step. But we don't know whether we want to go east, south, north or west. So I'm going to v-stack all those possible options. You'll see why. East, south, west and north. Okay, so we have where we can go from cell C2. And now we need to check what is actually in C2. What is actually in these cells. So what we can do is we can XLOOKUP this whole array and see what terrain types do we encounter. Okay, we see that there's only one terrain type, so there's only this cell where we are headed towards. Now we need to see which cell that was. Okay, so I didn't really do it really well here. What I should have done is use the let function. So we're going to say let. Okay, the cells are the v-stack. Then the terrain is XLOOKUP of the cells. And if there's nothing, I just want to, if there's no find in the XLOOKUP, I just want to give back the empty string. Okay, so let's see if it still works. Terrain, okay, it only gives one cell. And now there's two things that you need to take into account. You need to make sure that the terrain is not, so my selection is basically terrain does not equal the empty string. And what we also want to know is that the cells are not the one you just came back from. So the one before C2, you cannot go backwards, right? You can only go forward. So that is the selection. Those brackets. So you see now that there's only one valid cell. So what we're now going to do is to give the next cell is basically you're going to XLOOKUP the one in the selection and get the result from cells. That's the next cell. And that is C3. Okay, that's nice, should work. Only thing that we need to check now is if my previous cell here was the golden idol, yeah, then we stop, then we just show nothing. So what I'm going to say here is if the XLOOKUP of the previous cell equals the golden idol, and the golden idol is this one. Let's F9 that, because then I want to see nothing. If the previous cell is already nothing, then I also want to see nothing. And otherwise I want to see the whole LED formula. It's a bit ugly, but I think it works. Now we need to make sure that our dollar signs are correct. For example, we are XLOOKUPing here, so these ones need to be dollar signed, these ones need to be dollar signed. And that's it, the rest is all relative. So what we can do now is copy this formula down. And since temple 2 and temple 3 are actually very big, we're going to get them down towards, what shall we do? 207? Why not? Okay. You see that's not going really well here. I should do the check for the empty first. Or just say that the XLOOKUP returns nothing, so not an error. Okay, so here we get our path for temple C2, for entry C2. And let's copy this a bit further as well, because there might be more. If you think what's taking me so long? Well, that's actually because the data table calculation is still on. It's very annoying. So to switch that off, I go to calculation options and I do partial calculation. So I want the data table only to be calculated in the very end. Okay, so I have my paths now for example 1. And now it's time to do the calculation, how long it's going to take. Okay, how long it's going to take. So it passes through these cells. Let's do it first for this column. I want to know what kind of surface it is. So what kind of surface do we have? We have this surface. Let me do it. Let me take this formula and actually do it in an empty column so you can see what's happening. So we have these surface types. Well, let's give nothing back if there's nothing. Okay, so this is the surface types. And now we want to see how long it takes to pass through them. So we're going to XLOOKUP these surface types again in the table, in this table, where it says how many seconds it takes to move across each terrain type. Problem is that there's different animals. So instead of just looking it up in this row, we need to first check which row to look it up in. So we're going to look up the surface type in this row, and the return array is actually an XLOOKUP again. We want to XLOOKUP the animal in these animals and the corresponding row. Okay. Well, we get a lot of NAs again. That's because, of course, you XLOOKUP nothing. So let's say if there's nothing, I just want to take 0 time. Now it's a simple question of just summing this. We get 700. Okay, this is for cell C2, but I want to do it actually more general. So I'm going to do it for all the cells. So for that I use the function to call, by call. That means that I'm going to repeat the same thing actually for each column. So I say by call, and my array is, basically I want to do it in this array. So I'm going to use a trick for that. I'm going to say that my array is M8 hashtag to M207. And that actually gives me back the entire rectangle. The way by call works is that I need a lambda. So I'm going to use lambda. My input is call, the column, and I'm just going to change this to call, and I'm going to change. Yeah, that's it actually. That's the only thing that I need to do. And now it will give me the same calculation, but for every column. See? Super. Yeah. I think this is level 1 to 5 already. Let's see. Example 1, 700. Example 2 is 700. Example 3, 1120. Oh, where's my answer actually? The answer is XLOOKUP, the starting cell. Here. So 1120. And this actually needs to be copied for level 1, 2, 3, 4, and 5. So example 3, 1120, that's correct. Example 4 is 1050, that's correct. And example 5 is 1750, that's correct. So this is the first 5 levels. Now for level 6, what we need to do is we need to go back. The exact rule is you need to escape. So you need to escape through a different cell. So you start in the maze in Y2 and you escape in B56. This is also a starting cell. So for level 6, it's not enough to just get the route from Y2 to a golden idol. But what you need to do is add the other cell, B56. So do the same thing, because direction doesn't matter. 11,410. Okay, now you have level 6 as well. For level 7. Level 7 is a bit more complicated in the sense that you only have a starting cell, so you have CW33. Well, CW33 is this one. You'll end up in BI51, BI51, BI, where is it? 51. And then you need to escape, but you can choose which route to use to escape, so you choose the shortest route, but you can only use the ones on the opposite side. So you need to decide what is the opposite side. Well, thankfully this middle part is 20 by 20. So what I'm going to do is I'm going to calculate the row difference and the column difference between this, between the finishing cells. And if that is 19, then that means that they are on opposite sides, so you can actually use that entrance or that exit. So let's see. Okay. So what we need is that's actually not so simple. What we need is the finishing cell. So we need this AQ42 here. Well, the way I did that was, let's do row here and column here. The way I did that was to get index. And which one do you want? Well, it's 200 cells in total. Minus the blank ones of M8 to M207. and you end up in AQ42. Yes, spot on. Okay, so that's the row. It's not yet the row number. How do you get the row number? Row indirect. So it's 42. And basically the same as we did here. I'm going to do a to-call with M8 to M207, lambda, my column is here and my column is here. Let's try that again. Oh, lambda, to call. Bicall. Stress of the moment. Bicall instead of to call. Two of my favorite functions. So we have a row and we have a column. For column it's very simple. We just use column. And now we need to see, okay, this starting cell, where does it actually end up, in which row and column? So I'm going to do XLOOKUP of the starting cell. M2 hashtag to M3. So this one, CW33. CW33 will actually end up in 5161. So now we can calculate the difference and see if it's valid. So to calculate the difference, I'm going to do, well, basically what we need to do is we need to do these. The absolute value of the maximum of this minus this is 9. Well, it should be 19, otherwise there should be 19 fields apart. So let's see how we can do this in a bicall. So my columns are M2 hashtag to M3. I'm going to do a lambda. Now I think I'm doing it correctly. Lambda, the column, and I want to do the maximum of the column minus the ending location of the starting cell. You see, and we should not take the absolute value of the maximum, but we should take the maximum of the absolute value. I think that will work much better. Yes, now we see our 19s. So for example, this is a possible escape route. This is a possible escape route. 1, 2, 3, 4. We have 4 possible escape routes. Super. So when is it valid? Actually, it's valid if it equals 19. So for level 7, what we want to do is we want to get first to the treasure. We want to say, well, what's my minimum time to exit. So we're gonna say what are the min ifs of this times where the validity is actually true, and it's 7,420. Okay, so what I'm going to do now is I'm going to create a formula to get all the answers. And you get the game number, look it up in B3 hashtag and get the results from C3 to C132. Fix them and copy them. The data table might take a little time to load, so I'm going to press F9 now to force the data table to refresh. Shouldn't be too long, but still always longer than you want. That's why it's very important to switch off the data table recalculation, otherwise it drives you mad. Still see data table 1 here, means it's still working. Hopefully I did everything right. Otherwise we need to wait again. Ah, that looks good. Okay, so level 7 is good. 6, 5, 4, 3, 2, 1. Okay, I got all the points. That's nice. Okay, to be a bit more flexible now and not have to calculate the data table every time, because I'm going to make other data tables to solve the bonus questions, I'm going to copy and paste values, the answers, so they're locked. So the first bonus question is, in Temple 1, how often does the most frequent terrain type appear? Now, the temple walls, golden idols and starting locations are not terrain types. I prepared a very handy function for that. It's called my frequency table. And basically it just wants an input. And what it does, it gets all the unique values, even if it's a two-dimensional array. So I'm getting Temple 1. Gets all the different inputs and it counts how many times it shows. So we see that this beautiful terrain type, which is called grassland, happens 47 times. So that's the answer. Okay, how long will it take the eagle to reach all golden idols associated with the unique starting locations in level 1 and 2, excluding examples? Okay, so unique starting locations, well, level 1 has only one unique starting location, level 2 has more. Level 2 has actually 7 unique starting locations and C2 is not there, so in total we have 8 different starting locations, and as you might recall, all the paths are 10. So the eagle takes 70 per terrain, piece of terrain. So 700 times 8 is 5,600. These were the first two bonuses. They were not too difficult. In Temple 1, find the path with the fewest number of terrain tiles. What's the longest amount of time it would take any animal to complete it? Okay, so we're going back to level 1. I'm going to actually remove this data table to speed things up a little bit. So we're going back to level 1. We might still need this for other bonuses, so I'm going to keep it here. The shortest path in level 1 is this one. Okay, so what's the shortest, what was the question? What's the longest amount of time it would take any animal to complete it? Okay, what's the different animals that we have? That's these ones. Let's paste it somewhere where it's actually empty. Oh, not here. Not here. Okay. And let's say that this lookup is not necessary anymore. Okay. We're not going to start in C2, we are actually going to start in Z9. This one we don't use. So we're going to start in Z9 because that's the shortest path. And we're going to use this as the input of the data table. And the result should be actually this cell, V6. Okay, V6. Data, what if analysis, data table, and my column cell is the animal. Check. F9. This goes faster. Longest is 450. And instead of escaping through a different path, assume all animals must escape through the path they came from. What's the fastest possible round trip time across all paths in Temple 3? Okay, so we don't know the animal. We only know that it has to go as fast as possible. Well, Temple 3. We have, and these are the round trip, these are the times to reach the treasure. If you want to go the same way back, it's just ×2, right? So I'm looking for the minimum of this ×2 because we need the fastest possible round trip time for all animals. Fastest is 5,490. Let's do that in the formula. 5,490. And given the rules of level 7, what's the fastest time an animal starting at any location could retrieve a golden idol and exit the temple? Okay, so any animal and any starting position. So what we need here is a two-dimensional data table, I'd say. Let's get this one here. Let's remove the data table and let's say, okay, I have all my inputs here. What is actually happening? Given the rules of level 7, the fastest time an animal starting at any location could retrieve and exit the temple. So the level 7 rules are in order, are in effect, I must say. So we have to make sure that the model is still working. Okay. So what was the time to reach? The time to reach was here. XLOOKUP of Y2 and XLOOKUP of the fastest other one. Now we want to make a two-dimensional data table. We want to basically see all the entrance points and all the animals and just calculate the fastest one. What if analysis, data table, column input cell is the animal, and the row input cell is actually the cell. Okay, data table gives zeros, so let's press F9. And now we need the minimum of this thing, 5,940. Correct. Okay, so that's my solution. I don't actually know how long it took me. Let's see. Can I see those here? 34 minutes. Well, just a little bit over half an hour, but that's including the explanations. I hope you found it useful. I used the frequency lambda function and the trace path, which is very useful in maze situations to have that under the belt. So I'd say good luck with the Road to Las Vegas 2025, and hopefully my next video is not gonna be 1 year away. Okay, bye bye.